The Ganga is massive, sacred, and overwhelmed by organic and industrial waste. To clean a river of this magnitude, standard infrastructure is rarely enough to solve the problem. So in the late 1980s, the Ganga Action Plan introduced an incredibly bold idea: deploying a massive biological cleanup crew. The execution was staggering. Around 60,000 scavenging and flesh-eating turtles were bred and released directly into the heavily trafficked waters near the Ghats of Varanasi, specifically to consume human and animal remains. Rather than relying completely on concrete treatment plants, India attempted to use the river's own ancient living ecological machinery to address a modern crisis. But the moment those 60,000 turtles hit the water, they vanished beneath the murky surface, leaving virtually no trace. The release zone was a highly disturbed 7-kilometer stretch of river filled with heavy boat traffic. There were no barricading nets to keep the turtles in place, and environmental tracking technology simply did not exist yet. As this breakdown shows, a later government evaluation laid out the problem clearly. Millions of rupees were spent, but without systematic monitoring, researchers had no idea if the turtles survived, bred, or cleaned a single drop of water. The 1980s program did not fail ecologically, it failed technologically. The intervention ended the exact second the animals entered the river. This leaves a massive question hanging over the project. Was the idea of using scavenging turtles to clean a heavily polluted river actually scientifically sound? In 2020, researchers built simulated river environments to test how ecosystems respond to mass fish kills. In tanks with turtles, the animals rapidly consumed the carrion, and toxicity levels dropped rapidly to a normal baseline compared to control tanks. Modern scientific evidence confirms it. Turtles act as highly effective biological regulators of water quality. The scientists behind the 1980s vision were right, and they were decades ahead of their time. They simply lacked the physical and digital infrastructure to support and measure their work. Today, the modern Namami Gange program is releasing red-crowned roofed turtles back into the basin. But today, the approach looks entirely different. Individual turtles are now equipped with sonic telemetry tags, pinging their exact coordinates as they move through the waterways. But tracking the animal is only half the equation. The river itself is getting a hardware upgrade through ecosystem intervention platforms. These floating smart habitats provide safe basking refuges, native vegetation, and submerged routes. Attached is a digital payload, AI cameras, telemetry receivers, and water quality sensors. By integrating a natural habitat with a sensor network, conservationists know exactly where a tracked turtle travels and the precise environmental conditions that drove it to choose that specific location. The historical conservation effort stopped the moment a turtle was released. The EIP network uses the release as the starting line. As the cameras roll, artificial intelligence instantly filters thousands of hours of footage, ignoring floating debris and empty frames, to isolate verified turtle detections. This creates a continuous cycle. We restore the habitat, observe the ecosystem's response, learn from the data, and adapt our strategies. With constant real-time evidence, teams can actively manage the river, replanting vegetation, enlarging successful platforms, or relocating them. We are no longer relying on blind hope. We are actively managing a continuously learning, measurable restoration system. The human foundation of this entire network is the Ganga Praharis, a group of over 1,200 trained local community monitors. As shown in this project matrix, the EIP platforms push environmental intelligence directly to their mobile phones, turning local residents into digital custodians who monitor water quality and protect these specific habitats. This transitions conservation from a few isolated interventions into a basin-wide network of small, locally managed digital nodes. The next chapter of conservation requires a shift in thinking. It is not enough to put threatened wildlife back into a broken river and expect them to survive. By linking biological scavengers with a digital sensor network, we are completing a 40-year-old vision. We are finally building a connected, intelligent river capable of receiving and sustaining its ancient life.